In today's session, we are going to cover what are the linear programming problems and how you can solve them in Python using the scipy library. So, linear programming problems are generally problems where you are given an objective function, you are given certain constraints, and you want to optimize the problem. The optimization could be a maximization or the minimization of the objective function. So, in the linear programming problem, generally the objective function takes the syntax of z equal to ax plus by. Later on, we'll also see about how to optimize the nonlinear programming functions, basically the nonlinear functions, how to do the programming of it. This particular session is only for the linear programming problems. So constraints are given to us, and based on that, we find out the feasible solutions. So first, we'll just take a simple example where we will see how to solve it using a graphical method. So suppose you are given a function z equal to, you want to maximize a function z equal to 8x plus y, and the constraints are x plus y is less than equal to 40, 2x plus y is less than equal to 60 for all positive values of x and y. So if you do a graphical representation of it, if you replace um, y as 0, so x is less than equal to 40, okay. Then if you replace in the same one, x is 0, your y is 40, so this is the bounds. The second bounds will come from this function where you'll get y as 60 and x as 30. And if you do an equality of, if you replace this less than equal to by the equal sign, so x plus y equal to 40 to x plus y is 60, and you solve them, you will get this point 2020. So this is the region. These are the feasible region, the green part. So if you draw the lines, these are your boundaries. So when you take um, the method where you solve, where you take these boundary points and solve for this equation, you would find that you will get a maximum value of this function at the point 30 comma 0, where x is 30 and y is 0. That is where z is the maximum. All right, so that is using your intersection point method, using the graph method. Now you can use Python's scipy library and get the same answer. So from scipy.optimize, you'll import the linprog, and it does not allow for the maximization. So we have to convert this problem into a minimization problem. So we just change the signs. Okay, so minus z equal to minus 8x minus y. And if you have a greater than equal to constraint, that also will not be possible. So you'll have to make appropriate adjustment for the constraint as well. So now our objective function will become minus z equal to minus 8x minus y. So your objective function, you would take it an array and you would take the coefficients minus 8 and minus 1. Then on the left hand side of these two constraints, whatever is your value here, the coordinates that you will take. So for this x plus y, so it is 1 and 1. So this is 1 and 1. Okay. Then 2 and 1 for this. This is 2 and 1. And the right hand side is 40 and 60. Okay. So you'll create, so you'll put on variables like this. And the bounds are x is between 0 to infinity. Okay. And y is also between 0 to infinity. We pass this in the linear programming function. You'll pass the objective function. You'll pass this left hand side, these arrays. If you have more than two, like if you have four constraints, then you will be having four arrays here. Okay, so depending on your constraints, your number of list will increase. Since we have just two constraints here, we will just have two lists, and you will pass the bounds. So once you solve for it, you will get this kind of a the entire equation. The important thing, this will be the output. The important thing that you have to look for is the success. There are some optimization problems where there is no solution. There you will get success equal to false. Even after multiple retries, it will not get. And when success is false, then there's no point in looking at the output. But if the success is true, then this is your answer. Okay. So x is 30 comma 0. So at this point, we have your maximum output. All right. So this is how it is solved using the linprog function in the optimize in the scipy library. Okay, in the optimized package, you will have the linprog function. So if you have some any other constraints and a different kind of a equation, if this is solvable, okay, I've just taken some random values. If this is solvable, then I would get a success. Otherwise, I will get a failure. So the success is true. Optimization is terminated successfully. And I have got now for a new equation which I have created. At this point, my objective function is maximized. Okay, I hope it helps. Thank you for watching.